This is the second of 3 short videos reviewing solving systems of equations. In this video, we'll focus on solving using the elimination method. So if you already watched the first video, in that video we looked at solving systems by the substitution method. The elimination method is a little bit different, but our goal is still the same: to find the solution, or the values of x and y, that satisfy the 2 equations we're given. Our example here gives us 11x plus 3y equals 16 and 2x plus 4y equals negative 4. The idea of elimination is that we want to be able to add or subtract our equations to eliminate x or y. So sometimes this elimination method is called the addition or subtraction method. But I think you would all pretty readily agree with me that right now if I added the 2 equations we have, x wouldn't cancel out because 11x and 2x makes 13x, and neither would y cancel out because 3y plus 4y makes 7y. So that doesn't really work. Some of you might see that subtraction could work if you're careful, but I'm going to go ahead and go about it using a slightly different idea here. So let's pick on y. If I have 3y in my first equation and 4y in the second equation, can we think of a number that we can multiply these both up to be the same? In a sense, it's like asking for the least common multiple. So I know that 3 and 4 can both multiply up to 12. So now I'm starting to think about if I had a positive 12y in my first equation and a negative 12y in my second equation, I know those would cancel out, and that would be eliminating the variable y. So I'm going to go ahead and work this example as if I'm eliminating the variable y. You could have just as well have chosen to eliminate x. So let's see. If I'm trying to get rid of y, I basically want to multiply my whole first equation by what it takes to get 3y to look like 12y, and that would be 4. So I need to multiply my whole first equation by 4. For my second equation, I'm trying to get my 4y to look like a negative 12y, so I'll be multiplying my second equation by negative 3. Let's see what we have if we do this much. The first equation multiplied by 4 would give us 44x plus 12y equals 64. And our second equation multiplied through by negative 3 gives us negative 6x minus 12y equals 12. So notice that we did have to multiply the entire equations through. Sometimes we forget to multiply the other side by the number, so be careful there. But now this is my new system. 44x plus 12y equals 64, and negative 6x minus 12y equals 12. If we add now, we'll get what we wanted, which is the variable y will eliminate. So 44x minus 6x gives us 38x, and negative 12y and 12y, these guys cancel out. 64 and 12 gives us 76. So now we're just working to solve this linear equation, 38x is equal to 76. So here I think you'd all agree to get x alone, looks like we just need to undo multiplying by 38, and we'll do that by dividing both sides by 38. That leaves x alone on the left, and 38 goes into 76 twice, exactly. So, yay, there's our answer for x. But are we done? Well, not quite, because we said we're trying to find really a value for x and a value for y. So, to find y, you basically take this value of x equaling 2 that we just found, and plug it back into either the first or the second equation, whichever one looks more friendly to you. I'll go ahead and plug it back into my second equation. So I'm going to plug x equals 2 into our second equation, and that's going to look like 2 times the value of x we just found, added with 4y is equal to -4. So I'm just plugging back into the second equation. And if I solve here, I have 4 plus 4y equaling -4. So I'll subtract 4 from both sides. And that'll leave me with my 4y all alone on the left. -4 minus 4 gives me -8 on the right. And then if I divide both sides by 4, we're going to be able to find, I'll squeeze it in right here, that y is equal to -2. So -8 divided by 4 is -2. So now I have the solution for y that corresponds to the solution for x. And depending upon the context and all that, a lot of times we end up leaving our solutions for system as ordered pairs. So here I'll go ahead and write our final solution as the ordered pair to -2. And what's kind of neat is this means that if you were to graph the two lines we started off with, 2, -2 would be the point of intersection. So that's a little bit about the elimination method. Hopefully you feel pretty good so that you can try out some practice on the elimination method. And then please visit our third video, which will be solving applications of systems.